In this video, we are going to look at a small but a very important topic which actually I had completely forgotten about. It's called resolution of a vector. This is also called resolving a vector. Now, what is this resolution of a vector? The splitting up of a vector into two mutually perpendicular components such that the combined effect of these two vectors is the same as the single original vector is called resolution of a vector. Now what this means is, what the statement is saying is, we have a given vector A. This is the x-axis, say for example, and this is the y-axis. So what can be done is, this vector A can be split up into two mutually perpendicular components. In fact, this vector can be split up into any desired number of components. Alright? But in here we are only concerned about splitting the vector into two mutually perpendicular components. So what we are saying is, resolution of a vector is the splitting of this vector into two mutually perpendicular components, such that when we add those two mutually perpendicular components, we get the same single original vector. In order to split the vector, what we do is, from the tip of our vector A, or from the tip of our vector OP, what we do is we drop a perpendicular on the x-axis and we also drop a perpendicular on the y-axis. So this vector OM along the x-axis is one of the components and the other component is vector ON. So vectors OM and ON are the two split mutually perpendicular components of this vector OP. Now what is the magnitude of vectors OM and ON? In order to find the respective magnitudes, let us suppose that our original vector A makes an angle theta with the x-axis. So if theta is the angle which our vector A makes with the x-axis, then we already know the magnitude of vector OP, which is magnitude of A. So in this right angle triangle OPM, we know the length of one of the sides and we know one of the angles. Okay, so therefore, if this is theta, then this base will be magnitude of A cos theta. That is, the magnitude of vector OM will be A cos theta. Likewise, the magnitude of vector ON will be A sin theta. In one of the videos, I have already shown you how to find the cos theta and the sin theta components of a given vector. So what we have so far done is, we have split a vector OP having magnitude A into two mutually perpendicular components, OM and ON, having respective magnitudes A cos theta and A sin theta. Now what we only need to show is that the combined effect of these two vectors OM and ON is the same as the single vector OP. To understand that, look at vectors OM and ON. These two vectors, they are forming two adjacent sides of a parallelogram and they are starting from the same point. So what we do is we complete a parallelogram. So since these are two vectors forming two adjacent sides of a parallelogram and starting from the same point, so parallelogram rule of vector addition tells us that the diagonal of the parallelogram starting from the same point gives us the resultant. So to say, the combined effect of these two vectors gives us the single original vector OP. And this is exactly what resolution of a vector tells us. Okay? So here we are getting that OM plus ON, these two vectors combined, we are getting the same single original vector. We can also calculate the magnitude of the resultant of vectors OM and ON by following the parallelogram rule. Now according to parallelogram rule, the magnitude of OM, vector OM plus vector ON is given by R, which is square root of A squared plus B squared plus 2AB cos theta. So vector A, I'm calling it to be OM and vector B is ON over here. Now magnitude of OM is A cos theta and magnitude of ON is A sin theta. So simply substituting the values, and by the way, Since the angle between these two vectors OM and ON is 90 degrees, so therefore we have 90 degrees over here, and cos 90 is 0. So therefore the third term on the whole becomes 0. We substitute their values. So OM squared is a cos theta squared plus a sin theta squared. So this gives us a squared cos squared theta plus a squared sin squared theta. We can take out a squared common, and thereby we get sin squared theta plus cos squared theta inside the bracket, whose value you already know. Pardon me for writing r squared on the left hand side of the third last and the second last lines, because there shouldn't be a square over there. So please read the left hand side as modulus of r, simply modulus of r. The calculation is absolutely fine if we neglect that square from the left hand side in the third last and the second last lines. And thereby we get r squared is square root of a squared, and hence r, the magnitude of the resultant vector, is a. So to say, the magnitude of the resultant of vectors OM and vector ON is magnitude of a. So by combining these two vectors OM and ON, we are getting this single original vector OP, whose magnitude of course is a. So therefore, this process of splitting up of an already given vector into two mutually perpendicular components, such that the combined effect of these two split vectors gives us the single original vector, is what is called resolution of a vector, remember. So if you hear the words resolve a vector, then you have to split the vector, remember. That is the process of resolution of a vector, remember that. So resolving a vector and resolution of a vector are one and the same thing.